These are in listen-only mode.
Well, hello and welcome to today's webinar on Hipot Testing 101. My name is Syed Abidi and I will be presenting today's webinar. For those of you who are joining us from the US, good morning, and for those who are joining us from other countries, good afternoon, good evening. Before we jump into the material for today's webinar, a few quick things to note here. We have, as always, we have a Q&A utility for you guys to ask us any questions concerning the material that's being presented. Any questions that are related to running of the meeting, audio or video, can be addressed to our host, Jim Kennedy, through the chat line. And also, this webinar is being recorded like all our other webinars. And it will be available for you to view usually within a day through our website. So once again, Jim Kennedy is our tech support guy today. He's the host for this webinar, and you can send him any questions through the chat line or email him at jimk@asresearch.com. Also, you could email him if you would like a copy of the presentation. Also joining us today is Pete Stevens, who's AR's Associated Research Domestic Sales Manager. He will be assisting us with any questions on the chat line. Okay, so just a quick review of, just so you know, we during our 2014 series of webinars, we are we're covering various different topics, and our last webinar was on verification testing. For those of you who attended this webinar, this will be a quick review. For those who were not able to attend any of the previous webinars, once again, all our webinars are archived on our website and are available for you to view whenever you want. Okay, so real quick, what did we cover in our last webinar, which was on verification testing? Well, we went over, we did a quick overview of the common electrical safety tests, specifically the ground continuity test, the ground bond test, the dielectric withstand test, or more commonly known as the Hipot test, which we are going to cover today, and the insulation resistance test. We went over the need and the importance of verifying your electrical safety tester. What is verification and why is it important? And then we went into looking at the TVB, Associated Research's test verification box, the TVB2, which provides an easy and safe and quick way of verifying your electrical safety tester. And then we went over a few examples of how to verify your electrical safety tester using the TVB2 box. So that's what we covered in our last webinar. And today's webinar is on Hipot testing. This is the first webinar on Hipot testing. As you can see, we've named it Hipot Testing 101 because the next one will be Hipot Testing 102, which will cover some more details about Hipot testing. But today, what we're going to be going over or trying to cover is we're going to try to understand the Hipot test. What is the Hipot test and what does it really test? Where is it required? Then we're going to look into some Hipot test failures, things like the leakage current and insulation or dielectric breakdown. And then we're going to get into some Hipot test considerations such as some test parameters, and we're going to cover the difference between AC and DC Hipot tests. There's a few more topics regarding Hipot tests which will be covered in our next webinar on Hipot testing. So having said that, let's real quick go over the fact that why do we really need to perform an electrical safety test? Well, as we all know, safety agencies have implemented and enforced electrical safety testing for one big reason: to protect consumers from potentially fatal electric shock. Many of these injuries and electrocutions are caused by either electrical products with faulty insulation or a product with a defeated safety grounding system. And the insulation that is in question is used to separate the power line circuit from everything else, such as the low voltage circuits, the isolated power supplies, the chassis, or the case of the product. And this insulation is what protects or prevents the current from an ordinary household outlet, which is, as we know, an unlimited source of power, from becoming hazardous by finding a ground or earth path with something that is not meant to be a ground path. So in a Hipot test, we're going to cover why the insulation of a product is so important and how can it be stressed and tested. So here we go. So what is a Hipot test? Well, first of all, the dielectric voltage withstand test is another name for Hipot test, but Hipot is the more commonly used word for the dielectric voltage withstand test. And this test is by far the most common type of electrical safety test performed by electronic product manufacturers. This test is basically designed to verify that the insulation of a product is adequate enough to withstand a very high voltage. This test is performed by stressing the insulation of the product far beyond what it would encounter during normal use. And the assumption here is that if the insulation can withstand a much higher voltage for a given period of time, it should be able to function adequately at its nominal voltage or normal voltage level for the lifetime of the product. Now this is where the term voltage withstand test comes from, because we're basically testing the insulation and seeing how much voltage can the insulation of a product withstand. Next, we're gonna quickly go into a quick poll. We're gonna pause here for about a minute, and our host Jim Kennedy is going to open the poll for you guys. And please take a moment to participate. It's very important for us to get your feedback regarding this poll, and we will continue shortly. Okay, I guess we're all done here with this first poll. So we're gonna continue with our Hipot testing. And all right, back to our Hipot test. Here's a quick picture of showing how the Hipot test is performed from a circuit point of view. And on the right side, you can see that we have our product, and on the left side we have our all-in-one electrical safety compliance analyzer, the Omnia 2, which is also capable of running or performing both AC and DC Hipot. So as we know, during a Hipot test, we apply a high voltage potential between the mains input and any exposed dead metal to check for leakage current. The resulting leakage current, which is due to the application of this high voltage, is measured to determine whether a product's insulation is able to withstand the high voltage without breaking down. This test verifies that the insulation of a product is capable of protecting the user from any leakage currents as a result of an electrical fault within the product. So as you can see in this picture, the high voltage is applied to the mains of the device being tested on the right side, and the return is being measured on the chassis point, on a solid metal point of the product. So basically the important thing here to know is that the leakage current is used to determine how good a product's insulation is. Here's an example of a Hipot pass condition. As you can see, the high voltage leads from that white connector on the Omnia on the top. That's where the high voltage is being applied onto the mains input of the product, and as a result there's a leakage current that's going to flow, which is being measured via the return lead that goes into the black port in the bottom of the Omnia. And this is just a simulation of a pass condition. Here's the simulation of a fail condition. This is showing that the same high voltage being applied on the device being tested, the insulation has, is either leaking too much current to the surface of the product being a product under test, or the insulation could have, could have just been an insulation breakdown, which could be a very, dangerous condition for any user that is in contact with the product being tested. Okay, now in addition to overstressing the insulation, the Hipot test can also be performed, or it is also performed, to detect material and workmanship defects. This test can also detect small gap spacings between current carrying conductors and earth ground. As we all know, environmental conditions such as humidity, vibration, shock, and contaminants in the atmosphere can close the small gaps on the insulation and allow current to flow. Fault current to flow. This can in return create a shock hazard for the end user of the product. The Hipot test can help manufacturers determine these defects and fix them before their product is sold to the end user. So this means the Hipot test not only stresses the insulation to see if the insulation will break down and whether if it's good enough or to take care of any fault currents, but it is also used for manufacturers during the design phase, and it can allow them to find some manufacturer defects and fix them before their product is actually sent out in the market. So, and the product making sure that the product is safe to use. This tells us how important the performing Hipot test is and why it is the most common type of electrical safety test, because of this very reason. Because it's a multi-purpose test and gives you a lot of good information about the product and can save a lot of headache for the manufacturer later on. Now, most safety standards call out for a Hipot test to be performed on Class 1 and Class 2 products. Remember, for those who attended our previous webinars and for those who did not attend, we covered what we define as the product classification type. Basically, Class 1 products and Class 2. Class 1 products are products that have a ground pin, a ground circuit, and basically they're terminated in a three-pronged line cord, which consists of a hot and a neutral input and an earth ground connection to the chassis. Whereas Class 2 products, which are also known as double insulated products, have no earth ground connection to the chassis, since the chassis itself is usually made of some insulating material such as plastic. So that was our quick review of our Class 1 and Class 2 products. The Hipot test is required by safety agencies as a design test and also a production line test for every product that's manufactured. Now, once again, a quick review on design tests and production line tests. Well, design tests are usually performed to detect product flaws during the design stage of an electrical product. The information that that we get from or that's retrieved from a design test is useful for finding potential problems with product design and development, whereas production line tests are usually required to be performed on 100% of the products leaving a facility for sale to consumers. So Hipot test falls under the design test and production line test, which again stresses how important this test is. So the important point to note here is that the Hipot test can also be used to detect design flaws in a product in addition to stressing the insulation of a product. Once again, I would like to remind you all that if you have any questions during the webinar regarding any of the material being presented, please feel free to use our chat line. Pete Stevens is very knowledgeable regarding electrical safety testing and will be happy to answer any questions. Or I can also, at the very end of the webinar, we're going to do a quick question and answer session.
The questions so far, Syed, have been pretty good. I've been answering a few of them, but anything that comes in that anyone would like to ask, by all means, I can interrupt Syed at any time and have him answer it at a more in-depth level.
Well, you just heard it from Pete Stevens himself. So feel free to ask questions during and after the webinar. So once again, the Hipot test is required by safety agencies as a design and a production line test. Here's a quick look at what can cause a product's insulation to fail. Well, issues like heat, scrapes, pinholes, crimps, and improper spacing with respect to the ground. In this picture, you can see a wire that's got some open conductors that's pretty badly damaged. These kind of issues are also caught by the Hipot test, and these issues can lead to serious issues if they're not caught at an early stage. These can prove to be shock hazards for the user, and these can also prove to be damaging to the product itself. All right. So we know that all electrical devices will produce a minimal amount of current, of leakage current under normal operating conditions. Even devices as small as our cell phones have some leakage current flowing on the surface, but it's just so small that we don't, it's beyond the perception level of human beings, so we don't feel it, but it's there. Why is that so? It is due to the voltages and internal capacitance present within the product. Now, leakage current becomes a problem when it goes beyond the acceptable level, meaning that when it goes, the leakage current value increases to a point where it can prove to be a shock hazard, or it could prove to, damage other equipments. That's where leakage current needs to be monitored, and the product needs to be designed in a way that it does not allow too much leakage current to flow on the surface. And that's where the insulation of a product comes into play, and which is what the Hipot test actually, checks and stresses to make sure the insulation is good. Due to design flaws and environmental factors, the insulation of a product itself can become weak over time and break down, which can result in excessive leakage current to flow on the surface of a product. Now, this failure condition can cause electric shock or even death to anyone who comes in contact with the faulty product. So dielectric breakdown is the failure of the insulation to effectively prevent the flow of current. And once again, the important thing to note here is that all electrical devices will produce some amount of leakage current to some extent. Now, the best indication of dielectric breakdown itself is a leakage current measurement, which will be significantly higher than the nominal current measurement. Now, that leakage current is dependent on various factors such as the test voltage, the product being tested, and the internal capacitance of the product can, all these factors can impact the total leakage current measurement. When a Hipot test is performed on a product, we can actually think of, the product under test as a giant capacitor, because essentially when a voltage is applied to the mains input of a device, a charging current flows to bring the potential up to that test voltage that we're trying to apply. Now this voltage is, as we know, is applied between the mains input and the chassis of the product, which are separated by the insulation of the product. And this is similar to a definition of a capacitor: two conductors separated by an insulator. So, once again, performing an Hipot test on a product basically creates a giant capacitor, and we need to, this is very important to know because this gives us some insight and some important points to remember while performing the Hipot test. Once again, so the purpose of a Hipot test is to check for excessive leakage current flow through a product's insulation, and a dielectric breakdown is basically the failure of the insulation to effectively prevent the flow of current. And then also the maximum leakage current is dependent upon the test voltage. So these are very important points to remember. All right. Now let's look into some general Hipot test considerations. Well, test voltages for Hipot tests are usually stated by the safety standard that one is trying to comply with, and they can range from anywhere between 1,000 volts to all the way up to 4,000 and even higher. But mostly they should be stated by the standard that you're trying to comply with. But when in doubt, when you're not sure what to set for a Hipot test voltage, a good rule of thumb to calculate the Hipot test voltages: multiply the nominal input voltage of a device that you're testing and add 1,000 volts to it. So for example, if you have a device and you're not sure what to, and you want to run a Hipot test but you're not sure what test voltage you would like to set for this, and you know that your nominal operating voltage of your device is 120 volts. So using this rule of thumb formula, we can calculate it. As you can see, you do 2 times 120, which is 240, plus and add 1,000 volts to that, comes out to be 1,240 volts, or 1.24 kilovolts. In some cases, safety agency requirements call out, they call out for the exact Hipot test voltage for certain devices. For example, medical equipment, if you look at the UL 60601 standard or IEC 60601 standard for medical device testing, it actually calls out that the Hipot test voltage for applied parts that have a direct contact with a patient should be tested at 4 kV. Now the amount of time the high voltage should be applied during the testing is also specified by many safety agency standards. Also remember that most of the double insulated class 2 products are subject to design tests at voltage levels much higher than the rule of thumb that we just described above. So like I said, Associated Research makes Hipot testers that can go up to 20 kV, 20,000 volts. And trust me, we have customers who actually utilize that much voltage. So key point to remember here is that Hipot test parameters are usually called out by the standards that you're trying to comply with. But whenever you're in doubt, a rule of thumb formula that we just showed you is a good approximation of what voltage you should be using. Now the amount of time the high voltage should be applied during the testing is also specified by many safety standards. The most common test durations are 1 second for a production line test and 1 minute for a design test. However, some standards, like I said, may call out for a different time, but this is just a standard. Further, agencies like UL require that the Hipot testers meet certain output voltage regulation specifications to ensure that the device being tested is stressed at the correct voltage. Now, this output regulation capability is very important when Hipot testing for 1 second, because it's a very short period of time and we need to make sure that the test operator doesn't, during a 1 second period, the test operator does not have enough time to correct the output voltage if it rises or sags. So for 1 second test or any short Hipot test, the Hipot's output voltage must not be less than 100% and no more than 120% of the specified test voltage. That's just another additional point that I wanted to pass on to you guys. When the test voltage is applied for 1 minute, the Hipot meter can easily be monitored to see if the output voltage has varied or not. And for a 1 minute test, the operator has enough time to adjust the output voltage to correct the level if necessary. Now, Associated Research makes products or Hipot testers that have a programmable dwell time and leakage current or failure settings with very low resolution to allow you to, set your failure limits very accurately. Most electrical product manufacturers are sometimes confused about the trip settings for the leakage current. In such case, Associated Research recommends that the manufacturer perform tests on a handful of known good products, measure and record the nominal leakage current value, and then once an average nominal leakage value has been determined, the leakage current limit threshold can be set to a much higher value than the average. So once again, if the standard you're trying to comply with has not called out for a leakage current limit, then the best way is to take samples of known good products and determine an average value. And so basically most Hipots today, just like our Associated Research Hipots, have a programmable leakage current limit and threshold. The operator can adjust the limit to the value specified by safety agencies. If the device that's being tested has a faulty insulation and a breakdown occurs, the leakage current will exceed the threshold, and the Hipot will indicate that a high limit failure or an overload failure has occurred. And once again, the important thing here to know is that the Hipot test parameters are mostly called out by the standards, but whenever you're in doubt, you use a rule of thumb for setting the voltage and the failure limits for the current. All right. Next,
Syed, if you don't mind, I do have a question for you, if you have a second. And this is a pretty good one. What's the effect of altitude on the Hipot test voltage?
The effect of altitude on a Hipot test voltage.
Mm-hmm.
Well, for a Hipot tester itself, the environmental conditions and other conditions such as altitude and all those things are specified. However, the effect of altitude should not be something very significant when performing a Hipot test. However, that's one thing that I would still need to look into in more detail and come back with. But that was a very good question. Somebody just asked that what's the effect of altitude on Hipot test voltage, and like I said, that's something that we will get back with you for make sure we give you the correct information on that. So let's back to our Hipot test. Let's see the difference between AC and DC Hipot tests. Now, manufacturers may or may not be required to perform a specific type of Hipot test depending upon the product being tested and the standard to which it is being tested. Most Hipot manufacturers, such as Associated Research, we offer testers with AC or DC output capability. Both the AC and DC Hipot tests have inherent advantages and disadvantages, which are evident depending on the product that's being tested. But it is important to know or understand the difference between the nature of AC current and DC current. Well, if you look at the picture on this page, that's just a simple representation of a DC voltage. As we can see, it's just a straight line. It does not change in polarity, but it can change in magnitude. This could also have been a negative voltage as well, but it does not change in polarity, unlike the AC voltage. So it's poll time again. This is our second poll for today's webinar, and we will once again take a quick pause, and we encourage all of you to quickly take this opportunity and take part in this poll and provide us with some very important feedback. All right, looks like we are all done with our second poll of today's webinar, and I thank you all for actively participating in this poll. Before we jump back into our material, I just want to go back to that one question that was raised regarding what is the effect on the Hipot voltage at high altitudes. Well, like I said, that's something that's still out there, and it's being research is being done on that. However, we don't know much about for high altitude applications on the performance of Hipot testers or high voltages. But at low voltage effects, are very common when it comes to a high altitude, and when you're looking at low voltages, they can be affected by altitude, air density, and other environmental factors at high altitude. And the effects are basically the accuracy or the regulation of the voltage can be affected, and it could be a poor regulation or poor accuracy, things like those. But at this moment, we are not sure of how very high voltage would behave at high altitudes. Once again, it's a very good question, and we will do some research on that, and we should be able to provide some more feedback on that. But here, let's jump back into our main core of the material. So we just looked at a DC voltage, and we know that it can change in magnitude but not in polarity. Whereas AC voltage, it changes in magnitude as well as polarity. The picture here shows how a nice and clean looking AC sine wave would look. Now when we're dealing with AC voltage, we need to also consider the fact that we need to keep in mind the frequency, because all AC voltage and current is affected and related with frequency. So we know that AC and DC currents are different in nature. Well, the behavior of AC and DC current varies in a resistive and a capacitive circuit. First of all, as we just covered earlier today, that when we're performing a Hipot test, we're essentially creating a big capacitor. Now the device being tested, it actually, most devices that are tested for Hipot test and breakdowns, they have some resistive element and some capacitive element. So that's important to consider when performing a Hipot test. because that can affect the current readings. How? Well, as we know that AC current is a bidirectional in nature. So it can, it goes into positive and negative polarity, whereas DC current flows in just one direction. The relationship between current, voltage, resistance is defined by the famous Ohm's law, which is nothing but the voltage is equals to the current times the resistance, and it can be tweaked around to find the current, which is I equals voltage divided by the resistance, or the resistance voltage divided by the current. In a capacitive circuit, the AC and DC current behaves differently. Look at these two pictures in the bottom. The first one shows a simple DC source connected, applying voltage across the two plates of a capacitor. And on the right side, we'll see how the current in a capacitor behaves. So as you can see, as the capacitor charges up with time, the current decreases. And at the start, when you first apply the voltage, the current goes to the peak because charging the capacitor requires a lot of current. And once the capacitor starts charging up and time goes on, this current decreases, and the point comes where the capacitor is fully charged and there's absolutely no current flowing. So once again, when a DC voltage is applied across a capacitor, a current flows, but it goes to zero once the capacitor is fully charged. Compare that with an AC potential. When we apply an AC potential, first, if we apply an AC potential through a resistor, the resulting leakage current is in phase with the applied voltage. But when an AC potential is applied to across a capacitor, the resulting leakage acts a little funny. Leakage current acts a little funny. Unlike the DC, here the current is actually 90-degree out of phase with the applied voltage, as you can see in the second picture, or the plot for the AC voltage and current in through a capacitor. As you can see, the current is lagging the voltage by a factor of 90 degrees. This current that's flowing through a capacitor is called the reactive current, which is due to the capacitance of the capacitor. Next, as we know, most electrical products have a resistive element and a capacitive element. So the leakage current that is measured by most AC Hipot testers is the vector sum of the resistive leakage current and the reactive leakage current. So most Hipot testers will give us a value as a vector sum of the resistive element of the current and the reactive element of the current due to the capacitor. But Associated Research has developed some Hipot testers that are capable of measuring and displaying the real and the total leakage current. This is for our customers who require this extra bit of information. Some manufacturers like to look at the total leakage separately and the real leakage. And due to that reason, we have come up with Hipot testers that are capable of doing this. The picture here shows how the vector sum relationship is between the total current and the resistive element and the capacitive element. Also, there are many differences associated with the AC and DC Hipot tests, and they basically stem from the capacitive nature of a product's insulation. While the leakage current due to the insulation of the product is purely resistive and it is in phase with the applied voltage, as we just saw, the circuit that we are testing also has some internal capacitance. Therefore, the application of an AC voltage to the capacitive element of the product, it once again creates a current that is the reactive current, and it's 90 degrees out of phase with the applied voltage. And basically, it's the physical design of the product itself that is responsible for controlling factors that determine the capacitive nature of a capacitive current of a product, or the reactive current of a product, and the resistive current. Today, as we know, many products have higher capacitive leakage currents because filter capacitors have been added to the input circuits to enable them to comply with agency regulations. And also, the resistive leakage current within a product is primarily dependent on the type of insulating material that was chosen for that product, and also the applied voltage. The exact value of the resistive leakage, or the real current, is usually the determining factor that dictates the quality of the insulation at a particular voltage. So here's a few advantages of AC Hipot and DC Hipot. As we know.
Hey, Syed, could I break in real quick?
Sure.
Just briefly, someone has actually requested, could you possibly go back to slide 7 and review it real quick? I wanted to catch you before you started on this slide, sorry.
Sure. Okay, here we are back to slide 7. And once again, this slide is showing us how the Hipot test is performed on a device, and how, as you can see, the two signs for capacitors that are indicating that how this product, or any product that's being Hipot tested, can be thought of as a giant capacitor, because as you can see, the voltage is applied to the main circuit of the device, and that is between the mains circuit of the device and the chassis of the device. So and between the mains and the chassis is the product's insulation, which is why we can think of this product that's being Hipot tested as a giant capacitor. So we had a request for going back to the slide, and I guess we can now move on. So back to where we were. Back to the advantages of AC and DC Hipot. Well, due to the very nature of AC current and AC voltage, we don't require to ramp up the voltage due to the changing polarity of the AC voltage. Also, discharging of the device, if an AC Hipot test is performed on a device under test, discharging is not necessary. Also, due to the nature of AC current and voltage, insulation will be stressed in both polarities. We know that the AC voltage swings back and forth between positive and negative, so it stresses the insulation in both polarities. AC Hipot measures real and reactive current, as we just covered, and also AC Hipot is more commonly accepted by safety agencies, whereas the DC Hipot can be performed at a much lower current level, which means less risk to the operator. Once again, this is due to the very nature of the DC current being flowing in just one direction, either positive or negative. It is DC Hipot test is much easier to perform on devices that are highly capacitive. The leakage current measurement is purely real. So the DC element basically ignores the reactive. Once the capacitor is fully charged, the current across the capacitor is approximately zero. So there's no reactive current flowing. Therefore, with the application of a DC Hipot test, the current value, that's the leakage current that's measured, is purely resistive. DC Hipot testing is more cost effective, but it is not always accepted by safety agencies. Now, few other important points about Hipot testing. For products that are once again highly capacitive, a DC Hipot test is preferred to avoid the problems associated with AC Hipot, getting into reactive and real current and all that stuff. But with a DC test, you can avoid all that and just look at the real current element, the leakage current element. With a DC Hipot test for a highly capacitive DUT, a long ramp-up time is required to allow the charging current to gradually charge up the device. This is another disadvantage of DC Hipot test, because then it requires it increases the total test time by a big margin. Also, the DC Hipot test, it requires much less power and it reduces the inherent danger to the test operator. Highly capacitive DUTs or products also require a long ramp, sometimes a long ramp downtime. This is because, once again, going back to how we can think of the product being tested as a giant capacitor, we're basically charging up our product by applying a high voltage to it. Therefore, once the product is fully charged, we need to ensure at the end of the test for user and operator safety that the product is fully discharged. And that's why we have a function called the ramp downtime, which most associated research Hipot testers, they come with this standard with this feature for ramp downtime. And it is more important, as you can see, it's more important to use this feature for a DC Hipot test, not so much for an AC Hipot test. So once again, a big disadvantage of DC is, considering the ramp up and the long ramp up, ramp down times, the total test time increases significantly. So, all right. So a few quick points here regarding, as we all know, associated research, makes electrical safety testers from, that are capable of performing all the required electrical safety tests, starting with the ground bond, the ground continuity, the AC and the DC Hipot, the insulation resistance test, and line leakage test. And most of our Hipot testers, they come as standalone Hipot testers, and they're also testers that are capable, one box solution that are capable of performing, the full line of electrical safety testing. For example, such as the Omnia 2 electrical safety compliance analyzer is capable of performing all these electrical safety tests that we just talked about. We also have testers that are capable of outputting up to 20 kV. So that is a real requirement in some cases. Manufacturers require that much voltage to actually stress, the insulation or points on their product. For more information, please visit us on our website, which is asresearch.com. We have a great sales team and customer support team that will assist you with any questions that you may have regarding our products. If you already own our products, we have a great support that we are always very happy and willing to provide any type of application support and questions for our users and customers. And next thing what we're going to do is show you a quick video of a demoing a Hipot test, how a Hipot test can be performed using one of Associated Research's electrical safety testers. So bear with me here while I pull up this video. Okay, so we're going to look at this video, which is going to utilize the Hipot 3 model of Associated Research. It is a AC and DC Hipot tester. Okay, back to our webinar here. That was a video showing how an AC Hipot test can be performed using one of AR's Hipot 3 testers. And once again, I see that some of you were not able to hear the audio for this video. So Jim Kennedy has posted a link on our chat line which you can use to look at this video and some other instructional videos that we have put up on our website for you to better understand how our Hipot testers and other testers work. We will now leave the webinar time open for any questions that you might have. And once again, I'd like to thank you all for attending today's webinar and being patient.
Yes, Syed, I do have one suggestion here.
Sure.
A lot of attendees had asked about the setting of max current or the failure settings on a Hipot tester. How to do that, how to come up with that level. Does it come from specs?
Okay.
And if there's any percentages or calculations involved with that. And actually, that's probably a combination of 4 or 5 different questions that I received from everybody. So it might be good to review that.
Sure. All right, so we have, we just got a question regarding setting the current trip points for Hipot tests. Now, I think we covered this in, in the beginning of the webinar, but just to quickly review it, most standards usually call out for setting the trip limits. Sometimes the standard would call out for just looking at the breakdown. So that's all you need to look at is the breakdown of an insulation. However, it is very important to set the trip limits for leakage current. Therefore, a good way of doing this is if you have samples of known good products, then or any products that you guys manufacture, the best way is to run a Hipot test. Leave the high and the low current limits to the max, and the for this purpose you could leave the low limit to 0, or maybe a very small low limit which is not going to give you a low limit failure, and then run sample tests, samples of tests on these known good products. Once you have enough samples, you can average out and get a good value for the average leakage current for the device or for your product. Once you have that average value, you can a good rule of thumb that we use at AR is to set the high limit for that product, the current high limit, 25% above the average value, and for the current low limit, you can set it to 25% below the average value that you've calculated. So that is one way that we recommend. Now, once again, the first thing is to thoroughly read the standard and try and see if the standard does call out for any trip settings or not. If you're not sure, then the method that I just described is a good way of setting some trip limits for the current. Any other questions? We are still here and willing to answer any questions that you might have right now.
Syed, I would cover briefly arc detection. There's been a couple of questions in reference to arc detection and what it is, and if there's actually even maybe a separate webinar on it.
Sure,
that kind of thing.
Sure. I was going to. That's a good point, Pete. There are some other topics within Hipot testing that we will be covering in our upcoming webinar. Topics like arc detection, arcing, and also 500 VA testing, setting, we'll go a little more in depth on talking about setting the trip limits. But to quickly answer arc detection, well, as first, let's just really quickly review that a dielectric breakdown or a corona or a high impedance arcing may form around a conductor. In some environments, corona can be defined as a luminous discharge caused by the ionization of the air, and the corona is a partial breakdown caused by a concentration of electrical stresses at the edge of an electrode in an electric field. Whereas the high impedance arcs or arcing and corona, they generate high frequency pulses which ride on the low frequency wave. These pulses they can have a frequency ranging from less than 30 kilohertz to more than 1 megahertz, and they may be very short in duration. These are what we call arcs, high frequency arcs. And like I said, this will be covered in much more detail in the next upcoming webinar, which is Hipot Testing 102, I believe. However, arcing is not an exact science. It is just an additional feature that that we utilize to give the manufacturer some extra information about their product. So also remember that a Hipot failure is different from a arc failure. if your product is failing for arc detection during a Hipot test, that does not mean that it failed. The insulation is bad, or it's going to break down. Arcing is like I said, it's a total different phenomena, and it has to do with these these high frequency pulses which ride on the low frequency waves. Also keep in mind that agencies only offer very vague regulations on arcing conditions involved within Hipot testing. Arcing can sometimes cause, like I said, false failures during production line testing, and in order to determine how arcing applies to a particular type of product, we need to start with an investigation of the required testing standards. But like I said, arcing is a feature that we utilize, and most of our Hipot testers also test for arc failures. But that does not mean that Hipot failures and arc failures are the same. They're totally different phenomena. Arcing, your product can still pass an Hipot test and be comply within standard, even though it fails for arc failures. So these are two different things. However, we will cover this in much more detail. This webinar was more on understanding what a Hipot test is, what is being tested, and what it does, where is it required, and what's the difference between AC and DC. In the next webinar, we will cover arc detection, we will cover 500 VA testing, we'll cover more examples of Hipot testing, for different applications, and other important information about Hipot testing, and we'll make sure you have all the information you need before you are ready to perform Hipot tests on your products. At this point, I would like to once again thank all of you for taking out time and being with us and joining us for today's webinar. I'm your host, Syed Abidi, signing off, and a big thank you to our hosts and our panelists, Jim Kennedy and Pete Stevens, for assisting me with this webinar. Once again, thank you very much, and we'll see you next time.